Hello, my name is Kelvin Nguyen, and this is my Chemistry Culminating Summative project. My topic is balloons and gases. Outline the history of hot air balloons. The first ever hot air balloon concept was made in 1783 by the Montgolfier brothers, Joseph and Stephen, and this balloon was actually made out of paper to see how this conception worked. At the time, they used something called Montgolfier gas, which was used in order to make the balloon rise. However, they were unaware that it was the heat from the fire they caused that made it rise. Some centuries later, the modern-day hot air balloon, which was created in 1961 by the man named of Ed Yost. It used a controlled propane burner and nylon fabric. And if you know how a hot air balloon works, the more you increase the temperature on the propane burner, the higher you go. And the cooler the temperature, the more you descend. And did you know that every time the temperature increases by an added 1 degree Celsius, the volume is 1 out of 273 more than it was before? And this means that at 273 degrees Celsius, the volume would have doubled what it was if it started initially at 0 degrees Celsius. This phenomenon was discovered by Jacques Charles. The chemistry here is that as more heat is added into the balloon, the temperature rises, causing the many gas particles in the balloon to collide with the inside walls of the balloon, expanding it and increasing the volume. The relationship between pressure and volume is that as the temperature rises, the increase in pressure and the higher you go, and less external atmospheric pressure. We know that the standard atmospheric pressure is 101.3 kPa, so it gets less than that the higher the altitude there is. We can relate this to Boyle's law, which states that as external pressure decreases, the volume increases by the same amount. Report any disasters involving hydrogen air balloons. A disaster involving a hydrogen air balloon was in 1937, where the Hindenburg, a giant Nazi airship, came crashing down, claiming the lives of 36 people. What caused this incident to occur was a leakage of hydrogen in the cabin after a spark occurred. There was a reportedly 7 million cubic feet of hydrogen gas leaked out. And what happened was that the ship was surrounded by an electrically charged atmosphere, and the ship itself was covered in a fabric material, causing that spark to happen. Hydrogen, as we know it, is a highly flammable gas, which is why it exploded and caught on fire. Now, what is the difference between helium and hydrogen balloons, and which is safer? In order for a balloon to float in the air, it has to be lighter, less dense, than air. Both helium and hydrogen are lighter and float in the air, but unlike helium, hydrogen is a very flammable gas. And as you've seen from the Hindenburg disaster from the previous slide, it's the same way. And it would be more dangerous if it were to catch on fire, because then it would explode. Because of this, at kids' birthday parties, balloons are filled with helium instead. Hydrogen is actually lighter, making it less dense than helium, and it would technically make a better balloon if it wasn't for the possible risks involved. Now here's a calculation. Let's say I take that helium balloon from the kids' party, and I want to find its volume after I've submerged it into the deep end of the guy's backyard pool. And the water is at room temperature. Now, as it's being submerged, there is more external pressure, so we know the volume will decrease. But let's prove that. Let's say I started off with a balloon with 3.25 liters of volume at STP, standard atomic pressure, and the external pressure increases to 124.2 kPa. We know according to Boyle's law that initial pressure times initial volume will equal the final pressure times the final volume. So in order to calculate this, I will plug in my values, and note that the initial pressure is standard at 101.3 kPa. Now, if we put in this calculation, we can see that 101.3 kPa times 3.25 liters, those are both standard, and then we're going to multiply it at 124.2 kPa and the final volume. Now, we don't know the final volume, so what we want to do is we want to divide both sides by 124.2 kPa, so we can isolate just the final volume on the right side. If we calculate the left side, it should give us 2.66 liters, which is the final volume. Now, we're going to round that to 3 significant figures because it's the least number in the problem. Nitrogen gas is one of the most inert and abundant gases in the atmosphere. Is it possible to have a nitrogen gas balloon? Why or why not? Nitrogen gas is an ideal gas, and it is possible to have a nitrogen gas balloon, but under certain conditions. You see, nitrogen is more dense and weighs more than the air around it, so it will simply just fall to the ground. Nitrogen gas is usually cold, and at lower temperatures there's less gas particles moving around, and so the volume decreases. In order for a balloon with nitrogen gas to be possible, the surrounding temperature must increase to counter the coldness, so that gas particles inside start moving more rapidly, and the volume of the balloon would expand and eventually float. We can relate this to the kinetic molecular theory, where it states that gas molecules are directly related to temperature. When the temperature increases, the increase of motion in the gas molecules and increase in kinetic energy. If a person inhales helium, why does their voice sound funny? Well, since helium is a lot lighter than air, it travels 3 times faster than the normal oxygen you breathe. And what makes your voice sound is the sound waves that travel through your vocal cords. The sound waves in helium travel 3 times faster than oxygen. So there will be bigger wavelengths, and so your voice will sound unusual. Sulfur hexafluoride is another gas that makes your voice sound funny. It generally makes it deeper than it usually is. List the uses of neon and argon gases. Well, both neon and argon gas are noble gases. Here are some uses for neon. You can use it for botanical gardens, greenhouses, discharge tubes, fluorescent bulbs, those glowing open signs you see when you go to a store, some diving equipment, lasers, high voltage indicators. At that point, neon gas will start to glow. And some uses for argon is filling electrical bulbs, fluorescent tubes. So basically the lights on the ceiling you can see on the right there, that's fluorescent tubes. Also low energy light bulbs, airbags even during inflation, refrigeration, thermal insulation in energy efficient windows, and it can be used as a protective atmosphere for welding metals or alloys. Is laughing gas N2O really cause people to laugh? And how does it affect the human body? Laughing gas doesn't actually make people laugh, but it gives them a happy sense of relaxation to the point you're just mildly chuckling, and also has some kind of a taste that's sweet. Surgeons use this before a medical procedure, and it puts you half to sleep so that you can still have the consciousness to answer questions asked during the operation. It's considered a laughing gas because it causes many effects of joy to your brain, and it makes your limbs feel tingly. The only side effects, which in some cases do happen, is headaches and nausea, but after being taken off of the nitrous oxide, N2O, and exposed to regular oxygen, you'll be perfectly fine again. Now, outline the differences between carbon monoxide and carbon dioxide. The main difference between carbon monoxide and carbon dioxide is that carbon monoxide only has 1 oxygen atom, whereas carbon monoxide has 2. Another thing is that carbon dioxide is a non-flammable gas, but carbon monoxide is a flammable gas. Our smoke detectors in our house detects carbon monoxide to prevent us from breathing in ourselves, so we can put out whatever is causing it. The reason these detectors are on the ceiling is because the carbon monoxide is lighter, less dense than air, so it rises up. Carbon dioxide is quite the opposite, as it is heavier. It is more dense than air, and therefore it falls to the ground. Explain the uses of gases to help medical science. N2O, nitrous oxide, the laughing gas, is used to help medical science as it treats pain and is considered a sedative and anesthetic for patients who are about to do surgery. It allows the body to be calm and relaxed so you don't feel the experience of the procedure. Another gas is medical air, which is a compressed air free of any debris or bacteria. It's used to be supplied to patients to keep them breathing, and it helps with providing respiration and calibration. It is used by surgeons for both serious and mild operations. Carbon dioxide is used for less serious surgeries that isn't much so interfering with the patient's inner system. It is blown into the body cavity to help assist with making the cavity larger and also to provide stability, so it's easier for the surgeon to see and have access to those certain areas. These are my curriculum expectations chosen. I chose 5 of them, actually. Here's the reference list. And thanks for watching.